Hey everybody, this is Sean Harrington. I thought I'd do a real quick video to show you um, what this Aquarius MX is really all about. On the main screen here, you'll see the GitHub site. It's pretty easy to find, github.com/onestage, which is my account, slash Aquarius with a capital A dash capital M capital X. That's what this GitHub site is. And a lot of people have said, "Hey, what's this? What's this MX device? We've already got the micro expander. We've already got the mini expander. What is this all about?" Well, for me, one of the struggles that I ran into when I was first getting back into Aquarius in 2018, 2019, about the time that I was making the composite video adapter and some of the other things that I've made before I started reverse engineering the motherboard and the mini expander. For me, cassette interaction is problematic. It's an analog format. It's a serial format. It's charming, and I think that it's great that we continue to release software for the Aquarius on cassettes. But it's very tedious. Most of the the data recorders that are out there, whether they're the Mattel branded / Radifin branded ones, the belts are old on them. Some of the capacitors, sometimes if they've been sitting in a hot attic, will be problematic, and they won't get the voltages right for the audio output. And then the analog medium of cassette is very tentative. It's really easy these days to accidentally set a cassette someplace close to, a transformer or something like that, a magnet, a very strong magnet, because we forget we've been in this digital realm so long. We've had CDs for over 30 years now. CD-ROMs, DVDs, thumb drives, they aren't generally affected by magnetics. So I like cassettes, but I find them problematic. So in 2016, Bruce Abbott, who is an Aquarius enthusiast who lived in New Zealand, developed a product called the micro expander. And I got my first micro expander from Roy Goodall, and this is it right now. Well, it's kind of hard to see because I've got blurring on in the background, but it's a cartridge-sized device. It has, let me turn off the blur here really quickly. Didn't realize I had that going on. I guess if I keep it in front of my face, it should be fine. It has a port for joysticks. It has a USB port, and that's the most important thing. And it also has an audio out jack. It has a ROM. Sorry, see if I can get that to focus. I guess not. It has a ROM on the bottom of it. And it's got the AY sound chip. It has memory on it. It's a great device. But there are some problems with it. It's very difficult for the average person to build. It has both through-hole chips and surface mount chips. It's got some very difficult to solder, for the average person, I should say, resistors. That's a resistor ladder for the audio circuit. You have to find the exact right USB adapter, CH376 adapter. You have to take the adapter for the USB port off and solder it up here with some jumper wires. And if you look at it, there are 3.5 boards that you have to get. Also, there are a couple of programmable chips, the ROM, the GAL right here. Again, those are through-hole components, and yet the RAM itself is a surface mount. And then another minor problem is this connector that Bruce used. These pads here, these leaf connectors that go into the expansion port on the Aquarius, are wider than they should be. If you get them tweaked just a little bit, the Aquarius can actually short out across 2 of them, and that can be problematic. So, great device. The MX still uses most of these components, but we've fixed some of the problems that it falls through. So the MX is it's a new PCB that is the same form factor as the regular Aquarius mini expander, the one that's really difficult to find outside of North America. It's the same form factor. It's a PCB, actually, rather than holding it up in the image here. Let me bring these pictures up. So if you go to the GitHub site, you can see these pictures yourself. Let me go through some of these pictures on this screen. It'll take me a second to drag it over here. So here's the back of the Aquarius MX. Here's the bottom. This is my label that I use. I do serial number. This one actually sold pretty well on eBay about a month ago, or a couple weeks ago. Here's the logo. If anybody wants to use it, this is the all blue version. There's also a black version. You can't quite see it because this is if you want to use it against a light background. Here's the color version. Here's the white version. All of these logos are available for anybody who wants to use them. Here's a picture of the finished Aquarius MX on the desk, slightly closer version. And here's the PCB that I was talking about. So if we compare that to the micro expander, it has many of the same components, starting from the top, and hopefully it still has the expansion port for the AY sound chip, but it also includes the traditional DB9 ports. Now, these particular ones, the ones that came with the mini expander, are a little expensive. They're automotive grade, so the plastic is of a higher quality resin. It doesn't melt as much, so these can be, $10 to $16 US dollars. That's pretty expensive. They're not necessary unless you want to plug in control pads. You can also use an adapter that breaks out those pins, and there are less expensive ways to do that. We still have the RAM, but notice now that it is a through-hole solder. It's a more standard RAM chip, and since we have the footprint of the mini expander to work within, it's not as crowded. We don't have 4 or 3.5 boards to work with. We have really 1.5 boards, including the CH376S USB system. I also include an expansion port. It's not the same. It has many of the same pins as the Aquarius port, but this puts it in a form factor so that if people want to develop their own additional components, if they want to put another sound chip on here, they can. If they want to put a voice chip, if they want to do other things, they can absolutely do that. We still have the ROM. The micro expander had it in a socket. We do as well. This is pretty much the same ROM that Bruce wrote, although I did make some additions to it to expand the USB basic command set. Here's our AY sound chip. Again, it's in a socket because for me, it's easier to test in this version, so I always put them. Notice I solder in the RAM, I solder in the address buffers and the clock divider. There's no really good reason to have these 4 chips in sockets. In fact, if it gets bounced around a little bit, you can actually damage these chips. It's better that they're soldered in. So the 4 chips that I recommend putting in sockets are the ROM, the AY sound chip, and then the 2 GAL chips. GAL is a logic chip, a programmable logic chip. If you have a traditional XGECU EEPROM writer that's usually available through USB, you can burn your own versions of these chips. These chips are not expensive. I think you can get this one for $5 to $10. I use a WinBond electronically erasable one, so I don't have to put it in a UV eraser. I can erase it on the fly. Similar with these 2 chips. These GAL chips are very easy to find. They're very inexpensive, and they are also electronically erasable. The original micro expander only had this unit, the RAM, ROM, and USB controller. This is basically exactly the same that Bruce wrote. It turns on and off the ROM, the RAM, and the CH376 USB interface. But then on the mini expander, there used to be 3 additional logic chips. They were typically down here within this space. They're about the same size as this. I think there's a NAND gate and a couple of others. What I did was I chose to, since we're already programming a GAL, it's pretty inexpensive to add another one and then include that AY logic on here. There are address buffers. So that's the main difference between, well, that's one of the 2 main differences between the micro expander and the MX. The micro expander, Bruce decided to not use address buffers. Address buffers hold the address that's being read from or written to in a state a little bit longer. Since the Aquarius, which is typically over here, is, we'll call it miles away in electronic terms, The mini expander, particularly with the S1 version of the Aquarius, behaves better if it has these two chips in. You don't have to use these. Even though this isn't the final PCB, notice it says macro expander, which was the early version of it. The full released version of this, which let's see if I can bring that up here. It's within the docs file and the PCB here. It's a PDF. Hopefully it'll open it up on that screen. Where is it at? Oh, it's over here. Hold on a second. Sorry about that. So the full release version of it actually says Aquarius MX. You'll notice that it's off a little bit. Notice that there are lines here within the address buffer silk screen. If you don't want to use address buffers, and you don't have to, but it does provide for a more stable system, you can bridge these with wires based on these diagonal lines, and you can, it's a little more work, but it's, it's like 16 pieces of wire that you solder that. I think the system works better with address buffers, which is why I use them, but you don't have to. Now, using address buffers provides a little bit of a problem if you want to use the expansion port, because it compromises the throughput of data coming from the Aquarius back and forth with the expander, particularly if you want to do higher speed modem transfers. This address buffer can actually get in the way. But for the core Aquarius MX functionality, it's not necessary. Okay, and then notice here, our pads, our edge connector pads, are much thinner, almost half the size of the ones that Bruce designed. These actually match the connector profiles of the one that are on the original mini expander to the exact dimension there. It is a two-sided board. It's fairly easy to get produced. I think if you order 10 of them with shipping from any number of suppliers, you can get 10 for about $40 or $50. If you or people you know are wanting to make these, you can get them pretty well. So what's the point of all this? Well, you do get the 3-voice sound that people love to have. In fact, the ROM includes a built-in PT3 player so you can play music. It includes USB, and for me, that is the most important function. So we saw this USB port that's back here. What it'll do is it'll allow you to attach a thumb drive that has been formatted FAT32. Some thumb drives are flakier than others, so you'll have to experiment. Some people recommend that you format it as FAT16. They've had success with that, but most thumb drives formatted at FAT32 should work fine. And if you take a look at the library within, let's actually go to the website. You go to the MX. If you go into the software library, these are the files that you burn to the 3 chips, the ROM, and then the 2 gals. But in here, this is the default USB directory. In all of the USB drives that I ship with the MX, it has all of these files. It's got a demo that I wrote, the Inafutu Games Loader, all of the stock ROMs that people expect, and a whole bunch of songs. So you can play plenty of songs within this environment. Okay, so what's the point of this? Yeah, the micro expander did great, even though it was difficult to use. Sound is neat. Many of the games use it, and the additional ROMs are neat. But what's the real point? Well, for me, to really expand the use of the Aquarius comes down to this. It is these additional USB basic commands, and I'm going to zoom in a little bit to make it easier to look at. So USB basic adds about 13 or 14 commands, and I hesitate to say they're new commands because CLS has been available, clear screen has been available in extended basic for a while. So with CLS, let's run through these really quickly. You can do a clear screen, and you can do this from either the command line or from BASIC. You can actually program this into a BASIC program. Locate, this will actually put the cursor to a particular position. I guess I misspelled this, cursor. And then we'll save that, and it should automatically re-update it on the GitHub site. Position the cursor anywhere on the screen within the 40 wide by 24 tall space. This may even do a full 25 row space. So if you use 0, it may do it on that row. You can read serial data in from an I/O port, and note that this is within parentheses. So you have to tell which port you want to pull in data from. This is one way to get information from the AY sound chip. And combining in with out, you can actually push data out to that I/O port. So this is how you would program the sound chip. This would be how you would read data like from joysticks or whatever. But you can also use the input port to read directly from the keyboard if you don't want to use some of the other routines that are built into BASIC. PSG gives you a quicker way to send data to the sound generator rather than having to do out. It's kind of a shortcut. So it is a series of registers and values, and you can put as many pairs in a row as you want to of this to send that data to the sound chip to make music. And there's many books and sites out there and how-tos on how to do this. When I do a demo in some of the later videos for this, I'll kind of show how you do that. Joystick. If you want to read the joystick, you can use this joy command. Previously, you had to do peeks and pokes to get that to happen, and it wasn't particularly good. You can either read from both sticks, stick 1 or stick 2. It's pretty neat to have. This is pretty powerful, the call command. In BASIC, typically, if you want to call a machine code subroutine, you have to poke a value into a register within the Aquarius and then do a user 0 routine. This makes it a little bit easier so you don't have to interrupt what you're doing in your BASIC program. You can load your data, which we'll talk about in a bit, into a particular high memory section, and then you can do a call. And what it'll do is it'll tell the Z80 processor to jump with that and jump to that point and start executing the machine code that is listed at that address. And you've got a wide range that you can use. Now, the Aquarius BASIC interpreter uses signed integers, which means that rather than going up to 650 or 65,000-ish, whatever the high end is on that, it actually splits it into a high and a low. If you want to go from the 0 point of RAM, which is in the ROM space, all the way up to the top of the 32K range, you can use this. Everything above 32K starts to go backwards from minus 32,768. So this is just a little thing you kind of got to get used to in terms of how the Aquarius addresses information. There's one code below that makes that a little bit easier, but in future versions of the ROM, we'll try and maybe figure out a way to overload this call to make it a little more hexadecimal friendly for people who use that a lot. Debug. So this is really more of a shortcut than a command. This jumps into the built-in Micro Expander MX's debug screen. I don't know if I have any pictures of that, but that's more for high-end programmers who want to do that. Edit, this is also more of a shortcut. If you want to edit a basic line number within Aquarius, you basically have to retype the whole line. The edit makes it a little bit easier, and it kind of changes the format. There are some ways that you can insert text. I don't really use it because I don't actually do programming on the Aquarius. I do it in a separate editor, and then I use a conversion program that converts the text into Aquarius basic code. And then a lot of people who use emulators will use the text, the quick type mode to put that in. So there's other ways to use that. I don't use this edit. And I don't currently use debug because there are other features within the emulators that I think do this better, particularly within Aqualite. Load. This is probably one of the most powerful and useful new commands. Load brings it in from, rather than from the cassette using a C load, that's why this command is different. You can load in a file name. It assumes that you are already in the directory that you want to be, and it assumes that this file is in there. And it will load it. If you don't supply either of these two additional parameters at the end, then it's going to load it in as though it's a basic program. or a binary executable. Most of the examples that I'm going to use are going to be filename.bas, which means that it's a basic and it will load it in at the beginning of the basic stack. But you can load in other files like .binary files, .cac files in. The MX ROM is smart to determine if it's a CAC file, it needs to load it in lower in memory so that it's got the loader information. Whereas if you supply this, again, signed integer, you can load in a file name like a binary to a different location. We use this with 12288 to load screen data in for like splash screens and other image files, because that's the beginning of the character RAM, which has the color RAM right after it. So you can load screen files into that space. Or you can load data into a numeric array, which you notice that it's listed as a pointer here. That allows you to load data directly into an array that you've already set up within BASIC, which is kind of nice. With load, you also have to have a save. It uses similar things, but when you're saving a file name from a particular address, you need to let it know how long it is. Again, these are both signed integers, so you'll need to do this sort of conversion up here. These two commands combined with run make this worth everything, because with load and save and run, particularly basic files, you can create chains of programs that behave like much larger programs. So you can overcome the 32K memory limitation that the Aquarius has. And remember, the Aquarius has about 12K, we'll call it 16K, including the RAM of the lower RAM that's unusable, because that's where the system ROM is, extended basic if you happen to have it loaded, and then the character and color RAM. There's a little bit of space after that, about 2K that you can use, and that's fine. But then everything from that point up to where the cartridge sits is about 32K. That's really the usable space that you can use. 32K is a lot. You can do a lot of interesting stuff in that, particularly if you can digitally load and save data into and out of that space. It's very useful. These are the three most powerful commands. So for instance, you could write a basic program that runs, and when it does what it needs to do, if it's a little maze game and you get to the end, you can then jump to another part of the program that says run this next one. Basically what it'll do is it'll do a new command in the background. It'll erase all the memory of the program stack. The basic cursor will just be kind of sitting there, and by cursor I mean the memory cursor, not the cursor on the screen. It'll load up another program, and then you've got your second level or third level or random level, depending on what you want the game to do. This is very powerful. This is why the MX is important. Now you can use all of these commands, and there's some others. There's a directory and there's a catalog. A directory is a full disk directory. You could, I suppose, load these items into an array, search through them, that sort of stuff. It's really more something you're going to use at the command level to see what's in a folder. Catalog is kind of a minimalist version of the dir command. Change directories, that's how you get in and out of folders. Delete command will delete a file. That's useful. And then the hex command. Again, I don't use that this much. It would be useful if there was an opposite of this command that went from signed integer to hex values, but we'll eventually get to that point. So you can use these commands right now in two environments. Actually, there's another environment that I use that we're working on that implements all of these commands, but for now, most people can use these in two environments. One is an Aqualite. An Aqualite mostly works in micro expander or MX mode, except right now, the save command. Taking the virtual environment and reading data in is much easier than it is establishing a file lock state when you want to write to a file. So right now, the author of Aqualite is working on this. It's not easy. There are other things that he's working on first. This will eventually be implemented, but for right now, you can load in data, but you can't save in Aqualite. I believe the save command does work. within the main environment. If you want to use the micro expander, you can set up a virtual disk that it can read to and write from. And then, of course, the real MX, the MX environment itself, of course, supports all of this. You can read to and write from. So the devices and the micro expander will all use these. So that's kind of the overview. The next video will actually go into me building the PCB with all the circuitry on it. From there, we'll show how to encapsulate it into the various options you have with putting it into a case or putting legs on it so it's at the proper height. And then after that, I'll do some videos on actually programming these commands. So I don't know how long this is. It seems like it's been about 30 minutes. I hope it's not quite that long. Hopefully this will get you excited about using the Aquarius MX. Again, if you want to, you can find out all about it. You can make this device yourself if you want to. I've made it simple enough so that moderately advanced techies can do this themselves. Previously, trying to make the micro expander was really difficult. There was no how-to guide. If you're not technically advanced, hopefully you'll be able to buy these for, I don't know, anywhere between $100 US and maybe 150 or 200. The parts on the bill of materials, and if you look on the main page, that's right here. The parts are in US dollars. You'll have to do translations for your own space. I'm hoping that we will have a number of suppliers, particularly in the UK and in Europe, where these micro expanders, sorry, these mini expanders weren't as prevalent. These were bundled together in the Aquarius bundles in the States. Sold them at KB Toys and other closeout things when the Aquarius was being sold off in mass from Mattel and Ratofin and stuff like that. So hopefully we'll have these. Now, what I don't have as part of the MX project right now, because it's kind of a separate thing, is a way to source the controllers. I know that's a big hot ticket for a lot of people's items, but to be fair, a lot of the software that's out there, other than the stock ROMs, a lot of the third-party cassette software doesn't really use it, and honestly doesn't really use the AY sound chip. I expect there will be more, and people will want to use the control pads. Based on the way the Aquarius MX, based on the way the Aquarius takes in input, it's not wired the same as like an Atari joystick. An Atari joystick uses high and low voltages to send a high signal. If you push up, it's going to go through a particular pin on that DB9 that says that this is high. The Aquarius kind of does it the opposite. First of all, that pin that you're adding 5 volts through is completely different on the Aquarius. Second of all, the Aquarius uses low-level signaling, and it uses what's known as chording. Of those 8 pins that are on the DB9, it's like a binary signal. So these two values, let's say these two values on the 8-bit chain will be low. The rest will be high at 5 volts. So there's no way that you could plug in an Atari joystick or a Sega compatible joystick directly into it. So stop asking about that. You would need an interface board that changes those voltages and sends them through a different type of a shift register to make that happen. So not going to happen. That being said, it's actually easier to make a control pad joystick like this on your own. The thing is, we still need to use surface mount switches to make that happen. I do have one of those available. It's just not perfected yet. So I will move on to creating a do-it-yourself control pad for those who are interested in it. And then again, maybe some folks will make those for people as well too. So that's it for now. The next thing, like I said, is we'll be doing the PCBs. So thanks for listening to me ramble.